Okay. Are we able to hear everything? Let me check if the audio is coming fine or not. Okay. Yeah. Yeah. Okay. Yeah. The audio is coming fine. Cool. Yeah. So let's continue. Sorry, guys. There was a power up at my place and power cut at my place, and that's why we were not able to continue. Yeah. So let's continue now. Yeah. So as I was saying, let me just start things over once again. So the given problem to us was that we are given a number n, we have to split it into m parts such that sum of those m parts is equal to n and the LCM of those m parts is less than equal to half of n. That was the problem given to us, right? Oops. The screen got tilted, right? Yeah. Okay. Yeah, so that was the problem given to us. Now, weird things are happening with my OBS. Okay. Rotate 90 degrees. Yeah. Okay. So again, yeah. So the problem given to us was that Hershey maths puzzle. Now, and a lot of you guys said that there are a lot of different types of solutions possible for this. Like for 6 and 4, we have 1, 1, 1, 3, and the solution that we could have. So it will be like solving, stuffing it 1 and then solving for 5 with 3, right? The solution that we had. So it, 2, 2, 1, something like that. So 1, 2, 2, 1 would be the solution for 6, 4 based on the solution that we discussed. So before diving into the problem and these multiple solutions, let's first try to solve this problem in a brute force way. What do I mean by a brute force way? Trying to find out all the possible cases which have the possible solution, like trying to find all the possible permutations which will support this, which will have this condition with them. So that's what we were continuing with here. So what I have is I have a main function and I have a solve function. I'm going to explain to you guys what they are doing. Right. So what I'm going to do is I'm going to make an integer n and m. I take the input from the user. I make a vector of vectors. As I said, this is basically every answer that we store is going to be collection of numbers. We need to store that collection of numbers in some container. That's a vector. Vector is nothing but an array. If you don't know what vector in C++ is, just consider it as a plain single array or a list in Python, right? And to store all those collections of answers, we need another container, right? So that's why it's a vector of vector. This is the rest variable, which is result variable, is what is going to store our final answers of all the cases, right? And then what we do is we find this, we pass this vector of vectors to our solve function. We pass the value of n, we pass the value of m, we pass the value of current sum, which is like initially we don't have any numbers in our hand, right? So initial current sum is 0. And we also make a new vector and give that also to this method, right? And what I'm going to do is, so this function is going to fill the vector of vectors rest for me, and then I'm going to print all the values from this. So for let's say I'm going to do auto v in s. So rest is a vector. Then for auto number in v, let's print all those numbers. Don't worry, you're gonna understand it. Okay, and then we have this. Cool. And then we have, let's concentrate on our solve method. So for that, I'm gonna also, just a second. Yeah. So this wire is really painful. Yeah. So yeah. So just to make you guys understand what I mean is, so yeah. So as I was talking, we have this code, right? So what this code is doing is actually it's taking all these numbers and going one by one, filling them into the temp list that we passed it to the function. So initially temp will be empty, and that's what we are passing, right? That's what we passed it to the. So if you see, initially the list is totally empty. The temp that we pass, right here, this temp that we pass is initially empty. So, and then if I take you to note, yeah, you'll see that we have, so what we do is then, let's say we solve this problem using recursion, right? So we fill our temp list with 1, Okay. And then we recurse. We recurse for all the other numbers that we have from the possible numbers we can choose. So we add 1 into this, or we can add 2 with this. We can add 3 with this. Similarly, we can add 6 also with it, right? Or totally different cases to not even have 1, start with 2 itself, right? Then again continue the recursion. With 2 we check 1, with 2 we check 3, with 2 we check 4. And then with 2 and 1 we'll say like, okay, let's not even include 2 also. Let's include 3 and then start the series with 3. Or let's say you include 1, you include 2, you include 3, but then you drop 2, you then include 1, 2, 1, 3. So yeah, sorry. So trying all the possible cases like that, right? So we're going to use recursion for that. The code is not at all difficult. It's just that you have to keep in your mind, how do we translate this into code, right? So that's what we're going to do there. This is the logic that we're going to translate into code. So let me just share my code editor. Yeah. Okay. So the thing is, first, if current sum equals n and the size of temp is equal to m, which means that if the current sum is already equal to the n, the number which is given for which we had to make parts, and the size of our temporary vector which stores the current result is already m, which means we have found m parts with sum equal to n, then we just store it in res. So res dot pushback is a method in vector which allows you to push the type of the vector into the vector, push an element of the vector type. So here the type is a vector. So obviously in res we can push a vector. So we push temp into result. Otherwise, if at any given point current sum becomes greater than n, there's no point in going further, right? So I'm going to say return, right? And similarly, if temp dot size at any point become greater than m, there's no point in adding more elements because we are interested in only m elements. So I'm going to return from here also. And now here comes the actual recursion part. So we're going to start with for int I equal to 1, I less than equal to n, I plus plus, right? So I'm going to do temp dot, so we're going to include the current element, right? So let's say temp dot pushback I. We include 1, then we solve this. So I'm going to pass res n m, and I'm going to do current sum plus the current number. We have included the current number, right? And then I'm going to pass the temp as well. So in temp we have already included number. So we have included the number as well as we have added to the current sum as well. This current sum variable I'm maintaining here. Instead of maintaining this every time a recursion call happens, you can run a loop on this temp and find the sum. This is just a little optimization, right? And what was the other case? That we will do this, but let's say we do not include the current element. So we do temp dot pushback is the method, right? And temp dot pop back, which basically the last element which we inserted. Let's pop that, and now let's continue. So just for an example, let's take a look. So what will happen? Let's say with 1, let's say our question is for 6 and 4. Okay. So for 6 and 4, let's say we want to solve this problem. So what happens is, let's say temp is empty initially, so current sum is not equal to n, so we come here. Current sum not greater than n, skip this also. Temp dot size is not greater than m, skip this as well. Now we push 1 into temp, right? And then we go call this method recursively. So now our sum becomes, instead of 0 which we pass, the sum becomes 1 and temp has 1 in it. And the recursive function call goes, okay? And then we reach here again and sum is not equal to 6, size is equal to 1 only right now, it's not. So all these conditions are again come here. So we push 1 into it and again call it. So it will be like 1, 1, 1, 1. 4 times 1 will be pushed. The 5th time 1 will be pushed, will come return from this function, right? Correct? So 5th time 1 will be pushed, we return because this condition will be true. So we return. And then in that condition, 1 would be returned. So then we go on ahead with the second. So we'll put 1, 1, 1, comma 2. Again, 4 elements are there. What is the sum? 2 plus 3, 5. Sum is still not reached. 4 elements are already there. The next time we insert any other number, we'll return. Before even pushing any other number, so we'll return. So again, removing that, and then we'll come to 1 1 1 3. That's how we reach. So that's how, I mean, we'll enumerate all the possible cases using this code. So I hope this idea is clear. This idea of recursion is clear. It's not very difficult. And now, yeah, so after our solve function calls fills all those, this vector with all the vectors which contain the selected result, we just print it. And yeah, so what I'm gonna do is I'm gonna start a new terminal. Okay. Okay, I'm gonna do a g++ -10 code.cpp. Okay. My CPU is a lot busy already with streaming, so I think that's why it takes so much time to compile. Yeah, as you guys can see, we have these many cases. So let me just copy these, and so 6 and 4 case. Let's call this file this. Let me just paste this. Okay, so for this also equals 6, right? This also equals 6. This also equals 6. But for 6, if you see, there are only these two possible cases, and it's their permutation. That's all, right? But again, multiple answers are possible. Cool. We got it, right? And you'll be like, oh no, the problem was wrong. You gave multiple answers and so on, right? But before coming into that, this solution that we did for finding all the possible cases for a given number, see, on paper, it looks very easy. On paper, if you compute, let's say if we come to our note, and on paper, if I try to, find the solution for the same case, like for 6 and 4, on paper, it's very easy. I can, start counting on my own, like 1, 1, 1. And, so with 1 is not happening. Let's try 3, and yeah, 1, 1, 1. On paper, we are smart enough to find this. But the actual problem is the constraints are 10 power 5. The numbers can be 10 power 5. On paper, it's very easy to say, for this, multiple cases are possible. But can you write an algorithm which, with the given constraints, can find those different algorithms? Like, for example, for 6, 4, there are two different things possible. But what if I give you 10 power 5 and 4? Will you be able to find all the different cases in the given amount of time? Because the time complexity of this code that I've given is exponential. Depending on the value of n, it's something n power m or of that order, and it's a very huge number. And the time limit that we have is 1 second. In 1 second, it's impossible to calculate all the possible cases. So that's why the solution which we discussed is like the only solution which wants you to think in, I mean, it's the solution which wants you to think in those terms. So, I mean, and this is not the only problem that you'll face in future that will make you think in a certain way like the problem wants you to. Like this particular problem is one of the like best examples of a problem wanting you to think in a particular direction. Then only you'll be able to solve that problem. Another case which I agree, I mean, was possible is this case. 1 second. Okay, yeah. So another case which I agree, which should have been, is like, let's say this case. So for all the cases when n modulo m is equal to 0, for all these cases, I agree, you can give the answer as like n by m times. The answer will be n by m times this, right? So for this case, I agree. And this is like solving a small subtask. The main goal is to combine your code with the logic that I gave you earlier of stuffing ones and then solving with 3. So the main goal, like what I'm trying, my point here is that, well, you might be able to find different cases, like different possible solutions for some cases, but can you write code in sufficient time with sufficient time complexity and sufficient memory constraints which will pass this problem? That's what the idea is. See, I agree that there are multiple cases possible, and we saw that day, that and today also for 6.4 there are, like we just did this, right? And we do have the 6 and 4 case where there are multiple options possible, but at cost of what? At cost of time. We had to calculate everything, and obviously the program doesn't want you to do that. The program doesn't want you to go through the brute force approach and think of all the possible combinations and solve this, right? Just a second. Just a second. I'll put my phone on D&D probably. That's a lot better. Yeah. Oh, cool. Yeah. Okay, can you guys, I think everything is fine, right? Let me just reconnect. Yeah, it's fine. Yeah, sorry for that. Yeah, so what I was saying is we have, yeah. So that's what I mean. There are multiple solutions possible, but it's not that you have to go with those solutions because it's not easy to find those multiple solutions. That's what my point was. I mean, that's what me and Janki Meena ma'am discussed about this, and she only told that we should just emphasize on this fact that the problem really wanted you to think in that term that you should solve that problem for n equal to 3 first and then continue. Sorry. I'm again and again getting calls even after on D&D. Very nice. This is so weird. Anyway, yeah. So yeah, I'm open to questions if you guys have any questions regarding this, the fact that we just now discussed. Any questions? It's so weird. Anyway. And ma'am, if you're there in the chat, I think I made my point clear, right? That's what we wanted to discuss. So, I mean, if you can type in the chat and say that, yeah, this was fine or anything. So I'm open. Like Ayushman that day pointed out there are multiple questions. Hariket, even you also said that we have these problems. So, I mean, that's what I wanted to clarify, that the code that we have is exponential. So the thing is, on paper, it's very easy to find multiple cases, but can you code that? And even if you code that, will it follow the time constraints given? So that's, I mean, the problem wanted you to think in a particular way, then only you could solve the problem. And there are going to be a lot, see, this was just a starting. There are going to be a lot of different, in future, there are going to be different problems which would require you to think in a given way that the problem wants, then only you will be able to solve the problem. So I hope I made myself clear, and I hope I hope that you learn this. I mean, I hope you get to learn something new, which is basically if you have to split a number n into m parts, this is how you should be able to do it. This is a brute force approach, exponential time complexity. But yeah, and again, this is not the approach that we were looking for in the problem that day. So yeah, I hope I made myself clear. And yeah, Ayushman, I think you got your point. Right? So yeah, any questions in the chat? I'll wait for a few minutes before we solve. So yeah, for those of the people, for those people who are not from VIT and just wanted to take a look at the question, what was the question? So I'll be happy to show the question. Hers in maths puzzle. I'll just quickly show the question to all the people so that they can also know what the question is and we are discussing about. If those people are watching stream right now. So in just a minute, I'm just opening it. Okay. Yeah, so there we go. Let me just window capture this. So, window capture, we have okay, this is Word, Microsoft Word. Yeah, here it is. Cool. So as you can see, the problem that we are talking about is, so yeah, so this is the problem given to us. Can I zoom into this a little bit? Yeah, cool. I hope this is visible now to everyone. So the problem that we are discussing is in basic terms, it's Hirsch is given two numbers n and m, and he's trying to split n into m numbers such that the sum of these m numbers is equal to n, and the LCM of these numbers, which the m parts, is less than equal to n by 2. So that's the problem that we are trying to solve with this question. And the discussion today was about that students have said that there are multiple test cases possible. Like for 6-4, their answer could be 1113 and 1221 as well, 1122. But the main point that we wanted to talk about is can your code calculate those multiple cases in the given time constraint? And then we conclude that that it was not possible, because then if we do that, then our code will not have the given time complexity and it will not pass in the given time constraint. So is there any kind that we can think like the case where n is divisible by m? Yeah, exactly. Ma'am was a very good point. So like I said, there is this case of n modulo m equal to 0 when n is divisible by m, when you can simply give the answer as n by m repeated m times. But did you guys think of any other case where you think you can solve a particular case using, in which your answer will differ than the approach that I gave that day? Then answer will be n modulo m times. Yeah, exactly, Ayushman. That's what. For that case, this works, and for that case, I agree there can be a different answer from the approach we gave. But other than that, is there anything else? And the thing is, even this n mod m approach, if you think, that's only one part of the problem. That only solves one particular type of test case, right? And and specifically on that day, when we gave the problem in vProbel, this case was not at all present. That there was no case where n modulo m was 0. So that's out of picture. I mean, for that, but yeah, that's one possible case. But again, as I'm saying, that solves only one case. In this problem, you have to write code to solve the entire suite of test cases, right? So that's the main conclusion. That's the main point. That problem might want you to think in the way the problem wants you to solve. And this is not the first time you'll be dealing with this in your problem solving, journey. So don't worry. And yeah, so that's pretty much it. I think I made myself clear. This was the main agenda of this discussion. Yep. I mean, yeah, if you guys can think any other case, feel free to comment down on this video, or reach out to me or Janki Raman as well. I'll just give my email ID as well, so that you guys can reach out to me if there's any conflict or anything. Here's my email ID itself. Yeah, so that's all for today. I mean, this is what the discussion is, and hang tight, because on Friday I'm going to give another POD, which is again going to involve some concepts. So hopefully this time I'll be more cautious about these things and cover them already while making the problem statement. So watch out for this Friday. We'll try to give out another POD involving some good concepts. So yeah, that's all from my side. And anyone who's watching the stream has not liked the stream or not subscribed to the channel, make sure you do that. I think we should reach 10 likes with the amount of people watching easily. And yes, if you found this helpful, spread it to others also. You have friends who have this doubt as well. And yeah, that's all for today. Yeah, I think that's clear, ma'am. If you're still in the chat, we should be done with this. This is the point of the discussion, right? If any questions, by the way, you guys can, again, you're free to drop in the chat. I'm there for a minute or two. Okay, then I think there's no questions and things look good to me. Then yeah, I'll see you guys on Saturday probably with the solution of the POD that I'm going to give you on Friday. So watch out for the POD and all the best. Thank you.